These notes are over physical and chemical properties along with physical and chemical changes. So physical properties, these are properties that can be measured or observed without actually changing the chemical structure of the sample. So a lot of the times, all the physical properties are going to fall into the categories of intrinsic or extrinsic as well. Okay, because we can look at things like the temperature of a sample, the boiling point, the density, the color, even looking at mass or the size of the sample, we can observe these without actually changing what the substance actually is. Okay? On the flip side, chemical properties, these are ones that can only be observed or measured during or right after a chemical reaction. So they can't be observed without the sample reacting in some way. Okay, so it's having to change, and then we observe this change that occurs to them. Okay, examples of chemical properties are things like toxicity, so this is just the ability to damage living tissue, flammability, the ability to burn, and heat of combustion, which is the amount of energy released when burned. Okay, we're going to kind of talk more about chemical properties when we look at the chemical change that can occur. So for physical changes, they're going to take place to the form of the substance, but they don't actually change the molecular structure of the sample. So we're going to be changing the substance, just its form. So examples of this could be cutting a solid sample in half, like sanding something, changing the temperature of a sample, state changes, so like freezing, melting, evaporating, changing it in the different phases, or changing the shape of the sample. So like here we have water, it's in its liquid form, and then when we heat it up and it starts to evaporate, we still have water, but it's in the form of steam, which is the gas state of water. For chemical changes, these are samples that go through a change in their actual molecular structure. So we start with a certain substance, it's going to react and become a new substance. Okay, so generally the atoms are going to be rearranging, and we'll kind of look at an example here with water in a second. So some chemical changes are reversible, but many are irreversible. So a lot of the times if you look at a sample and you think, can I put it back together easily? It's going to be a physical change. Whereas if you would require other chemicals to react with the sample to get it back to where it was, that's going to be a chemical change. So evidence of chemical change. Things like color changes, and to be specific, color changes would mean like if I had a clear substance and I mixed it with a substance that was orange, and whenever they mixed together it turned blue, that would be a color change. Compared to if I have something that's yellow, a sample that's yellow liquid and then a blue liquid, and I mix it together and it turns green, those samples didn't truly change color. That was just the yellow and blue mixing together to make the color green. So that's not truly a color change. Okay. Another evidence is odor produced. Light or heat energy is given off, so you might see a flash of light, or you can feel heat coming from a sample. That means that a chemical change is occurring. If a gas is produced, or if a precipitate, which is a solid that is produced when two chemicals react together, creating a new solid, is formed. Okay, so moving on to the example of water. If water was to go through a chemical change, an example would be through electrolysis. So the water is actually decomposed because of the electric current, and it breaks it down into the hydrogen gas and the oxygen gas. So we had H2O, and then they break down into different substances of O2 and H2.